and a very good day to all. Today we would like to discuss on our project on the theory of structure for twisted beam. So here is our team members: Ahmad Mujahid bin Abdul Rashid, Muhammad Izzuddin Syamil bin Muhammad Ishaq, Amiruddin bin Tajuk Ashikin, Nur Christina Akila bin Muhammad Zamani, and also Muhammad Daniel Zulkarnain bin Muhammad Farooq Faizal. For this discussion, we will go on to the introduction, metric investigation, calculation, result and discussion, and also last part is the conclusion. For this case, twisted beam is a type of failure, which is the undesirable disparity between a building's expected and actual performance. It may also emerge from a component's inability to perform its primary and original function. This case is considered as one of the structural failure, which known as lateral torsional buckling beam or twisted beam. Based on this figure, it shows that the beams that constructed using steel has been in twisted failure mode. Therefore, our team has come out with the decision that we will place a suitable number of small amounts of columns underneath the beams as indicated in the figure 2, and this column will act as additional support and also restraint to the beam. Next, we'll move on to the metric investigation. For this assessment, based on this design data that we have obtained, it is a type of two-story building where the secondary beam are size of 365 x 171 x 51 of UKB with a steel grade of S275. The beam span is about 10 meter and is designed to carry a uniformly distributed load, which is 12 kN per meter square. While the material evaluation, steel is a ductile material, hence even the load has been predicted, forces in different members has calculated and already designed in order to resist particular force. However, it still tend to fail due to some unpredicted load that make the force in certain members increase to a value which it cannot withstand. As for the hypothesis of beam stiffness, for many different types of structure, especially those with slender geometries, the idea of beam stiffness is crucial. Large deflection as well as significant localized stresses and the possibility of failure in that area might result from insufficient beam stiffness. Such construction may also be vulnerable to torsional moment, which are twisting moments. In addition to bending moments or torques, the product of EI is a measure of how strongly the beam resists deflection under bending moments. For a given material, the beam stiffness is maximized by maximizing the value of I. The next hypothesis is compression flange of the beam is not restrained. The main cause of the torsion is when the compression flange of the beam is not restrained. We believe that when we apply a load to a beam, it is applied precisely in the beam center. However, this is not always the case in practice. The loads are present on the floor and these loads always eccentric. Because the flange of the beam is not fixed, this eccentricity causes a twisting moment that causes the beam to move laterally as well as twist.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amiruddin bin Muhammad Tajuk. Today I will present the calculation part of this project. For the calculation part, we have two methods, which is moment distribution method (MDM), and the second part is critical bending moment (MCR). For the MDM, we have several steps. First is calculate the member stiffness. Second, calculate the DF. Third, calculate the carryover factor. The fourth step is calculate FEM, and last, prepare the distribution table to summarize the final moment. In this diagram, we can see the frame diagram. With our group calculation, we determine that the framing diagram is an indeterminate frame, and our group proposed for the framing diagram to be one column with a pin and moment. Next is the calculation part for the FEM. After the calculation on FEM, our group using the table to get a final moment at every joint, and from there we find the variation at every joint, and we sketch the diagram for SFD based on the shear force diagram. Next, we sketch our bending moment diagram and find the moment at compression, which is 13.36 kN, and moment at tension, which is 7.47 kN. The critical bending moment (MCR). In this project, we use the size of 356 x 171 x 51 UKB with a steel grade of S275. The design loading is 12 kN per meter squared, and based on the table of properties, we get our MCR, the critical moment, equals to 375.37 kN. Moving on to discussion part. feedback. Based on the issue of the twisted beam, we can see that a beam design needs to be double checked before it installed on site, because the calculation of load may not occur at the center part of the beam, but it also may have been distributed on the side part of the beam, which can result in twisting. The stiffness of beam should have been tested earlier and repeated for various stiffness range in order to get the actual properties of the suitable material used for the construction. Recommendation. Our group has recommended two in this project, and it is preferred that the beam was constructed as a restraint beam to prevent any lateral torsioning buckling brought on by the load that the beam must carry with other loads involved. Lateral torsion buckling also can be increased by adding additional plates to it or by widening it with the help of angles, although welding on site is a difficult procedure that occasionally necessitates the temporary removal of structure or non-structural component attached to the beam flange. Conclusion. In conclusion, we can summarize that the lateral torsion buckling occurs when an applied load because causes lateral displacement and twisting of a member. The lesson we can learn from this finishing project is to enhance and polish our calculation based on the skill so that we can identify with more ease our shear force diagram and bending moment diagram values. Our final value for bending moment at tension is 7.47 kN and at compression is 13.36 kN. By comparing to MCR value, which is 375.37 kN, we can conclude that the purpose of adding one column as a support to the beam with the same size can be accepted and can be prevent from the failure happen. That's all for our group. Thank you.